Hello everyone. So today I'm going to discuss chapter 3 and in this chapter see the basics of Newton's law. Very important chapter for all of you to understand. So here we go. So Newton's second law. Newton's second law. Well, I don't need the law actually, but I should state that Newton's second law is nothing but a force needed to accelerate a particle is directly proportional to the product of mass into acceleration. Okay, so if I simplify these terms, it says F is equals to mass into acceleration. All right, I need to discuss this formula. This is a very important formula. In short, I can write F is equals to ma. All right, let's discuss this F. What is this F? Here, this F is nothing but resultant force. Resultant force. If you're not familiar with the resultant force, then here's an example for you. Let's say this is a box. Okay, this is a box, and a string is attached to the box. All right, here's another string attached to the box. Let's say someone is pulling the rope in this direction, and someone from behind is pulling the rope in left hand side direction. So this is left hand side direction, this is right hand side direction. Left hand side direction. All right, now let's say the pulling force of left hand side direction is 3 Newton and the right hand side direction is 7 Newton. So what is the resultant force here? What is the resultant force F here? Well, as you can see, the right hand side has greater number of forces compared to the left hand side. So I can say the resultant force is nothing but 7 minus 3, which is nothing but 4 newtons, and it will move in the RHSD, right hand side direction. I hope it make sense to all of you why if I talk practically, it's obvious. If I pulling something with greater force, it will go in the direction of that greater force, right? Okay, so it makes sense. I hope it makes sense, but I need to elaborate this further. Again, I'm gonna write F is equals to ma. Now let's say here I have a particle. All right, and this particle is moving with a constant acceleration a. So the right hand side direction, it has a force of 7 Newton, and on the left hand side it has a force of 1 Newton. Since this particle is accelerating, okay, so and I know the mass. Let's say the mass is 1 kg. So if they ask me to find a, the acceleration of this particle, then I can say that I need to find the resultant force first. What is the resultant force acting? Because this F, this F, it's not force, it's resultant force. Please remember this, okay? It's a resultant force. It's not just only F. So resultant force here is 7 minus 1, which is nothing but 6 Newton. So in the equation of F is equals to ma, the F value is 6 Newton and m value is 1 kg into a. I need to find the acceleration. So what is the acceleration here? 6 divided by 1, which is nothing but 6 meters per second square. So this is an example of resultant force, which is very important for chapter 3 in M1, and which is very important for you to understand the basic formula of F equals to ma, which is nothing but Newton's second law. Okay, there are more interesting things that I'm going to discuss later, but till now I will keep everything up to this point, and I'll see you all in the next video. Thank you.